Welcome to Learn Yourself. Today we are going to understand third law of motion, and this topic is under CBSE Standard 9 syllabus from the chapter 9, Force and Laws of Motion. Earlier we have discussed the first law of motion and second law of motion. Before coming to the third law, it is important to understand first law and second law. So if you have any doubt in these two laws, please go back and check into the playlist of Standard 9 and go through those two videos and then come back to this video in which we are going to understand third law of motion. So here let us first understand some of the concept of third law of motion. That first is when we are saying action and reaction forces are equal and opposite. This statement is according to the first law of motion. So I have given here as per the textbook the example in which spring balance is there. So in this spring, this is one spring and this is another spring. This spring has been attached to the wall, and from here when we are pulling it, so how much we are pulling it, that much it pulls back, So action and reaction forces are equal and opposite. That means how much hard we are hitting to a ball, that much it will go up. How much force we have exerted on that much it will give back. So action and repulsion are always equal and opposite in direction. Once you are hitting the ball to the ground, it comes back. That means it is opposite, and how much fast you are hitting it, that much fast it will come back. So it is equal in force and opposite in direction. Then second, a forward force on bullet and recoil of the gun. This we need to understand, that when there is a pistol like this, so this is a pistol or this is a gun. So from here we are firing a bullet. When we are firing a bullet from a gun or from a rifle, so when we are firing it, it comes back. That jerk comes back. With whatever force the bullet will go on into the air, we are shooting the bullet, and with that much force that rifle or the pistol will come back. So that force we are talking about, and that will be recoil of the gun. What is the meaning of recoil of the gun? After shooting the bullet, that gun will comes back. So this will happen within a fraction of a second, that once you are firing it, it comes back. So that movement will happen simultaneously. That bullet is going in the forward direction and gun will comes back. So that is recoil of the gun. That gun is coming back. Why? Because it is throwing bullet out of that with some force. So the same force it is coming back, because force will be in opposite direction. So it comes back. Then let us consider this example, that this is a skateboard and this is one fixed bench. So when you are trying to jump from the skateboard, you may fall because skateboard will move from its place. But when you are jumping from the bench or jumping on the bench, you will not fall because it is fixed. That is how you are walking on the floor, that you are putting pressure on the floor and you are going ahead. If your floor is moving, then you may fall. So here this is not fixed at its position. So you may fall when you are jumping on it or when you are jumping down from it. But here there are no chances of falling because it is fixed. So it will exert some force in opposite direction. It will help you to jump, it will help you to move. Whereas here it will comes back. If you are jumping on this direction, then it will move ahead. And it will not give that much force back to you which will support you in your jumping. So this will move and it will not give you force whatever you want in the jumping, but this is fixed, so it will give opposite equal force in opposite direction, so it will help you to move. Now we are going to understand that conservation of momentum. So momentum, we already know that momentum is a product of mass of the object and acceleration. that is a momentum. Via momentum or via change of momentum, we can change the velocity of the object and we can change the direction of the object. So this is all about momentum. Now let us see that what is conservation of the momentum. Let us understand this situation, that one object, that is A, is having mass A. This is the second object, that is object B, and it has a mass B. Now both of these objects are traveling in one direction, like this. They are traveling, but here the velocity of object A is greater than velocity of object B. So what will happen, that it will dash and it will collide with B while they are moving. This situation, you have to imagine that they are moving on a floor. Imagine these two are the balls. So they are moving on the ball, but ball A is faster compared to ball B. So what will happen, that it will go and collide with ball B while both are in a moving direction. So it is colliding with ball B. So when they are colliding with each other, this ball will exert some pressure or some force on ball B, and in reverse this ball B will exert some force on ball A. That means whatever force A is applied on B, that I am writing as FAB, because A has applied force on B. So that is my first force, that it is applicable to B object. Now B is in turn also applying some force on A. So that is my FBA, that B object has applied some force on A. So here there will be two force, FAB, FBA. So A object has applied some force on object B and B object has applied some force on A. So this is a situation. Now let us understand that when this will happen, what will be the result. So we are converting this entire situation into mathematical formulation. That what will be the force in this situation and what will be the force in this situation. So as discussed, there are two forces. So from this direction, from A to B, force is FAB, and this force, which is FBA, will be in opposite direction. To FAB. So these are two forces acting on these two objects. Let us convert this FAB into its mathematical formulation. So if I am writing here FAB, so what is the formula for force that we have studied? F equals to m V minus U divided by T. This is the formula of the force which we have studied, and this is rate of change of momentum. When this much force we are applying on the object, then this much rate of change of momentum will be there in the object. So here rate of change of momentum or force applied on another object is this. So here we are writing here MA, because this we are considering AB. AB means force in this direction, and here A object is applying force on B. So here we are considering MA, and velocities we are considering for A. It is going to be VA minus UA divided by T. Now similarly, another equation we will get, that force which is applied from B to A. So B object is applying force on A. So here we will get MB. Why? Because this force, B object is applying force on A. So here mass, what we are calculating here, is of B object. Then similarly, velocity of B object, that is final velocity, minus initial velocity divided by T. Here we got two different formula from this collision. Two different formula for two different objects when they are colliding with each other. Now what will happen, that when they are colliding with each other, they are exerting equal force, but they will be in opposite direction. They are exerting equal force. Equal force means FA equals to FBA. FAB equals to FBA. Now how this has been possible? Because when two objects are colliding with each other, as per the first law, that action and repulsion forces are equal in their magnitude. So they are equal. But also they are in opposite direction. They are in opposite direction. So one of this force, we are taking it in negative. And this force, I am taking it negative because actually balls were going in this direction. Actually balls were going in this direction. So this I am considering forward direction, positive direction. But this is in opposite direction. So FBA I am writing negative here because they both are opposite in their direction. Now let us put the values of FAB and FBA into this equation. So here I am going to write MA into bracket VA minus UA divided by T equals to MB VB minus UB divided by T. We have put all the values what we have written here. Solving this two equation, and here T is same at both the sides, so we can cancel it out, this T. Now let us solve this term. It will give us MA into VA minus MA into UA equals to minus MB into VB plus MB into UB, because this minus and this minus will become plus. So I have written here plus, but here this minus will be remain here. So when we are taking out A common here, now these two terms are negative and these two terms are positive. So if we are changing a side of this term, that this term we are taking it towards this side and this term we are taking it towards this side, then both will become positive. Then both will become positive. So this term I am taking it towards this side. So I am writing this, that MA into VA, then I am writing this negative term. It will change its side, so it will become positive. So it is going to be MB VB equals to, I am writing this term or this term. So this term I am taking it towards this side. So it is going to be positive. So it is going to be MA into UA plus MB into UB. So this is our final equation, in which mass of object A, velocity of object A plus mass of object B, velocity of object B. So here what this is representing, M into V, M into V, M into U plus M into U. So objects, both of objects final momentum equals to both of the objects initial momentum, because here as you can see, these two are initial velocities and these two are final velocities. V represents final velocity. So when two objects are combined together, their initial momentum and their final momentum will remain same. So that means final momentum equals to initial momentum. When this will happen? When before collision and after collision, the momentum will remain same. So it is conserving. What is the meaning of conserving? Conserving means whatever it is there, you are keeping it as it is. Whatever is there, we are keeping it as it is. That is the meaning of conservation or conserving. So whatever momentum was there in initial situation, after collision also the same momentum it will show. So it is conserving momentum. It is conserving momentum. That means momentum is not changing. Momentum will remain same before collision and after collision. So from this equation, we are going to write the statement of third law of motion, and which is about conservation of momentum. This is what we have derived from the situation, that final momentum equals to initial momentum. Final momentum means mass of object along with the final velocity, mass of another object with its final velocity, and mass of object with initial velocity and another object's mass with its initial velocity. So here this will give us momentum, this will also give us momentum, this is also give us momentum, and this mb into vb is also giving momentum. So addition of the initial situation's momentum equals to addition of final situation's momentum. So what is the statement of third law of motion? That the total momentum of two objects is unchanged or conserved by collision. So when there is a collision between two objects, so initial momentum and final momentum will remain same. That means there is a conservation of momentum in that situation. When there is no unbalanced applied force will be acting on them. There should be no unbalanced force. In that situation, the momentum will conserve. Momentum will be conserved in that situation, in fact, from the final situation and initial situation. So this is our law, and which is also known as third law of motion or law of the conservation of momentum. Hope this video has solved your doubt. In coming videos, we are going to discuss many important concepts. So don't forget to subscribe, Learn Yourself. I'll see you in next video. Till then, keep learning, keep sharing.